So, welcome to the second session in the English track of this afternoon. Driving a microgrid with OpenEMS. John Cockerill, a nice story actually. Downloaded OpenEMS, got it working within a few days, a few weeks, which is actually really an interesting thing. Just that would invite you to stage, but I think you're able to tell us a little bit more. I welcome Denis and Denis. I never try to pronounce your names again. So Denis and Denis, the stage is yours. Welcome. Thanks for being here.
Thanks, Thorsten. My name is Denis Jidovtseff. So I'm working at John Cockerill for a few years now. I am with my colleagues, Denis Jidovtseff, which is developer at John Cockerill for a few years also. And yeah, we are going to present you what we did with OpenEMS the last 2 years since we have discovered the software. At first, I will start with a small presentation of our company. John Cockerill is a quite old company which has a 200 years of history. It starts with steel, with railways and weapons. Now he's going to make a big transformation towards renewable energies, sustainability, environment, and also all stuff with for Industry 4.0. So this is a major actor in Belgium for the industry. We are more or less 6,000 people all around the world, and we have many activities, like I said, in energy, environment, defense. We still make some weapons, yes, industry and services for all of our kind of customers that we can have. Recently, we have a more next. Okay. Okay. We have a more complete portfolio of solution in renewable. It starts in 2008 when we start to make a solar receiver for CSP power plant. So this kind of power plant that use mirrors and concentrate all solar beams at the head of a tower. And with our experience in the heating recovery system for gas power plant, we made the heat exchanger that collects the energy from the sun and transform it into heat with molten salt, and that drives a turbine. Next, with the next solution we developed is a storage integrated renewable solution. So we start an activity in storage. We have here in Belgium a pilot of with many different renewable with many different storage solutions. We have redox flow batteries, lithium ion. We have also 2 megawatts peak of solar power, and we are using this pilot for developing and testing everything for renewable integration and grid services. We have also more recently created a nitrogen product line with the purchasing of with the acquisition of a Chinese company a few years ago, which is one of the top, one of the leader the mondial leader of electrolyzers. So we are able to supply a big electrolyzer with more or less 5 megawatts power. And this is something we are developing in a really fast now. 2 years ago, there was 4 people working for that. Now I think we are something like 50 people. So this is really a high expansion sector. And then we have also the renewable mobility, which is linking more or less everything together, because we are including hydrogen for the mobility, for the heavy mobility, for the trucks, or for the maybe cars also, and also renewable mobility for the cars with integration of batteries and charging station for the big companies, or even ECBs. A few years ago, when I started at John Cockerill, there was an entrepreneurship project. I started with another colleague. I call it Reduce. The target of this project was to make a startup out of John Cockerill, to have some new business and different activities that John Cockerill have usually. What we wanted to do is to reuse batteries from electric cars, so use second life batteries for standalone application, for static application. So the idea was to increase autoconsumption for the solar system, use the grid for benefits of the battery, and to improve the charging infrastructure for the electric vehicle for SMEs, or for example, to improve the consumption of a building. The idea was really to be a major part of the energy system of a building. For example, a supermarket which has a solar panel, which has a charging station, which is connected to the grid, which has also energy bills, and to optimize this with the batteries and the EMS, which is really important for that. But at this stage, we didn't have any EMS available. So we were ask ourselves, what should we do? We have 3 choices: develop an EMS from zero, or purchase an EMS that is existing, or use something that is existing, that is free to use, like OpenEMS, and that we can improve afterward. So we made this kind of matrix table with the advantages, disadvantages, with the small, with all these that we need to fulfill for staff, cost, reliability, implementation speed, or added value for Reduce. And you can see this table, and we quite quickly conclude that we did not have the skilled staff at the moment, and purchasing an EMS is not a good added value for Reduce, because there's too much, there's no control of that. So we try to go with OpenEMS, because this is the column where there are the more advantages, and we start to build a prototype of our battery, where after that. So this is our prototype. It's a small battery with 11 kilowatt hours, small power, 7.5. We did not build ourselves the battery modules, so the second life batteries. We rely on a supplier, but for the software and integration of OpenEMS within the battery, with the prototype, we call OpenEMS, which is working for also with OpenEMS, which is part of the system, the ecosystem, and with that, with OpenEMS, we could reach. We could have a prototype working within 6 months after having the building of the prototype. We also supply some development for the community, so the Cambridge and the Revolution Pi digital output hardware. We develop ourselves also some driver for the battery, and driver also for the inverter, which is specific. We use OpenEMS as a real-time controller, data collector, energy manager, and user interface. This is really what is really interesting with OpenEMS is the ability to have this link with Influx, the database, to have this monitoring really versatile with another tool, which is Grafana. And we can use it for monitoring everything very quickly and very easily. After that, we continue, and we have a demonstrator container, which is more powerful with more capacity, and which is an ongoing project. So it's being building currently, and we're still using OpenEMS as a master BMS in this case, because in the project there are many other companies that are focusing on really the EMS or the other control of the battery, and the scope of development is the collecting of the data that we have on all the BMSs, and make sure that all the container is safe, is working correctly. So we have safety management because the EMS is embedded in a Revolution Pi device, which has some input-output and CAN bus. And with that, we can do some thermal management. We have also this Modbus connection, which is really important to connect the different inverters and controllers that are inside the container. What is really important also is the data collecting because of development purpose. It's really important to have this data collection for the analyzing of and development. So after that, I will let the speaker to my colleague Denis.
Thank you, Denis. So I will change a bit the subject. Wait. As Denis mentioned, we have an activity also in the building microgrids. So Reduce is one project for which we used OpenEMS, and then there is also Miris, which is our pilot microgrid. So here are a few pictures. Let me zoom in on the picture on the right. Sorry, it doesn't want to. So I want to show you this from closer, so you can see on the roof of the industrial buildings, we set some solar panels. Then you can see in the middle there are some batteries there that are contained in containers. So they are pretty big batteries, And this as a whole forms a microgrid, which is something that we wish to sell as a turnkey product for our customers for various applications. So this is this mirrors in a nutshell. So what is it exactly? So it's first of all designed as a pilot project that will be used primarily to gain knowledge and expertise and basically to do some research and development. So it's not actually meant primarily to decrease our own electricity bill. It's just a tool for our tests mainly. And it's a life-sized proof that we are able to do some nice things with batteries for our customers. It is composed of about 2 megawatt peak of solar panels. For the loads, what is consuming on the site is mainly the offices. Then there is also an industrial site, and we already have some charging stations added to the parking lot that are yet to be connected to the same circuit, but it will be coming soon. Also, we have different technologies in terms of batteries. We have 4 different batteries. We have lithium-ion, which is the standard, the de facto standard, but we also have some flow batteries that are a bit more exotic that we are interested in, so as to offer our clients, our prospects, different options in terms of technology. So we have sodium sulfur with NGK and vanadium with Sumitomo, and then of course Reduce is another project that we added on the microgrid to test it and to promote it. So let's talk a bit about software. So in the case of a microgrid, we have several types of equipment that are interconnected on circuit. This is something that we need to collect data from what we call our local EMS. So the bricks there are mainly the data acquisition and also local control in real time. So this is basically what we do using OpenEMS Edge, the Edge part. And then we also have something that is externalized, that is placed in a cloud that serves to store the data that was acquired and then monitor it and visualize it using dashboards, and also placing in the cloud some of the more complex and resource-hungry algorithms like predictions and optimization. So we have several configurations that we've used to control a site. So it's not only mirrors, it's also supposed to be something that we sell for the microgrids that we will sell in the future. So we have a few options in terms of config. I will go over them in more detail. So read-only, meaning only acquiring data, but not really doing much control. Then there is some rule-based, simple strategy to control the site. And then the most advanced strategy is the optimized control. So let's go further in the details. So the read-only is just for monitoring. It has some value because we can query our equipment that uses standards like Modbus and CAN bus also. We can use that to acquire the data. Although if that's the only goal of a project, we also considered lighter tools such as Telegraph, that is in the InfluDB InfluData suite of tools. So that's not the main configuration we would use OpenEMS for, but that works. We tested it, we used it. We also used self-consumption, so optimizing the self-consumption using a simple rule-based algorithm, using some already existing modules or modifying some. It was pretty simple implementation using OpenEMS, thankfully. And also the nice surprise was that as we have a quite complex microgrid with several batteries, it was already kind of possible out of the box using the ESS cluster modules and the power module that were already available, and they were thought out of the box with these features in mind. So that was nice. And then for the most advanced one, this is more complex, combining some of services that we are developing internally to forecast what the production will be, the consumption will be, and maybe the market price, but not sure about that yet. Also, we can use those forecast services to make some optimization using a few hours ahead horizon. So that's yet again another service that we have implemented outside of OpenEMS, that we used in conjunction with OpenEMS. And then we use all these services. We need to integrate them into the real-time control, which is done by OpenEMS. So for the complex algorithms that I mentioned, there we used mainly Python and some available libraries, because it's easier, and it's a language that is that has more tools available for these kind of things. It is also hosted on cloud, which allows a few things, but we prefer to use it on the cloud rather than have to dedicate more resourceful hardware on the side of a client. And we communicate through REST APIs mainly. So about real-time control, we developed a custom module for OpenEMS, querying our own APIs to get to query the services that are hosted in the cloud. Obviously, it's not that simple. It raised a lot of questions along the way, because if the optimization can be done in the cloud, it's usually something that you don't do every second or so. It's something with a longer time horizon. So you need to take that in mind, and you need to have some strategies to deal with that, to implement it in your real-time control. So I want to show you, because this is mainly text and not very visual, I want to show you also what we did about dashboarding and monitoring solutions. So for this, we chose not to use OpenEMS UI, which was an option that was considered, because mainly we didn't want to spend too much time on development for this. So we used Grafana, which was also pretty easy to integrate with OpenEMS, and that offered, in our eyes, more flexibility for quick prototyping. So let me show you first what we can see here are the key metrics that we can see. So first, this is the overview basically, which has on the top the live values of our four main input and output, and so production, consumption, storage, and grid, classic, and then the state of charge of the storage as a whole. Then we have, in this case, 48 hours of history that can be displayed also. This is the overview. Then we can dive deeper in another dashboard and see like the state of every battery. What is it controlled by? So is it via the EMS automatically or manually using an HMI? And also you can see more details about specifically the battery. Also, we had to visualize the output of our different services. So here I won't go too much into details, but this is basically a view of our forecast. On the left, this is the daily forecast of the energy that will be produced, consumed, and then the net value. And on the bottom, the monitoring here basically tells you what the measurements were up to now, and how does it compare to the forecast. And then on the right, you have the forecast, of production consumption, the price, which is not really a forecast, it's more an input. And then we compute an optimal usage of our storage. And this basically to show off, to showcase how the optimizer works. This is what is queried from OpenEMS. So we query this, and then we have to handle the real-time control in the OpenEMS. Lastly, we can also use the data to aggregate and give more high-level view of the energy consumed, produced, and so on. So this is the reporting dashboard. So again, it's a nice thing that we are able to do because we acquired that data in the first place with OpenEMS. But this is more like in Grafana and in InfluxDB that we did these features. So overall, we wanted to close with just a quick lesson learned about our experience with OpenEMS. So we encountered a learning curve that was pretty steep. So for us, learning the way that OSGI worked and the way OpenEMS works on top of OSGI and so on was not that easy. It took us a while, but well, let's leave it at that. And also, we noticed that there is a strong community, so many changes are done upstream in the official repository. So this is also a source of that we need to spend some time and resources to just keep up with the changes. And sometimes the modules that are present already in OpenEMS are sometimes not mature enough to our liking or not well documented enough. Of course, this is something we can contribute to, but in any case, it's nice to find some modules that are already existing, but sometimes it's just the idea of the module is there, but not much else. So overall, the benefits were that we saved a lot of time, even so, because we didn't have to build the framework itself. We had standard stuff built in already. So like communication through Modbus was pretty nice to have already working and pretty well tested. And also the data persistence with InfluxDB was very nice. The modular approach allows easy extension, so that's we took full advantage of this in our own development. There are existing modules for a lot of common cases, so that's the main point of everything, is that if you combine everything and you look through all the repository of modules that are already existing, it's a lot, so it's very nice. And also the community is quite helpful, especially Denis, you said that you were able to leverage the community to ask a company that already knew OpenEMS to work with you. So that's it for us. Thank you very much for your attendance. And Thorsten, I think the floor is yours.
Yes, thank you very much. Thank you, Denis and Denis. I really enjoyed it because you, let's say the benefits is the network or the community, as you said it. And I could not make a better closing word because that's really, what OpenEMS is about and what especially an association like OpenEMS is about. And the value that you can get from open source compared to closed source projects, or let's say market-ready solutions. Denis and Denis, thank you for your presentation. I haven't received questions so far. I think you both are available. You are part of the community, so also I hope you now give also your feedback in terms of, or helping others that are in a similar stage where you came from in our forum on openems.io. Thank you again. Looking a little bit at the time, we're a few minutes behind schedule. I would close that session now. Dennis, your contact details are here on the screen at the moment. Don't hesitate to contact him. See you in a few seconds in our last session for the 2 tracks. Compensate CO2 with OpenEMS. What this is about, a little bit of automation presented by Fabian. In a few seconds in the other room. See you there.
Bye-bye.